Howdy students. In the last video, we discussed the controlling factors for carbon dioxide emissions. Remember that the emissions of carbon dioxide are a side effect of economic activity, and the factors that control emissions are those factors, things like population, affluence, and technology. We refer to this decomposition as the IPAT relation. If we can predict these controlling factors, then we can predict future emissions, which in turn allows us to predict future climate. Before we do that, however, it's worth making one last adjustment to the IPAT relation. The technology term is what converts dollars of GDP into carbon dioxide emissions. To gain a clear insight into the factors that control this term, we will split the technology term into the product of two different terms: energy intensity and carbon intensity. You can see how the numerator from the first term cancels the denominator from the second, so that the product of these two terms is indeed equal to the technology term. The real advantage of this decomposition is that these terms mean specific things. Energy intensity is a measure of how many joules of energy it takes to produce a dollar of economic output. This reflects the efficiency with which energy is consumed. For example, imagine two businesses that are identical except one uses inefficient incandescent light bulbs while the other uses efficient LED lighting. These two companies produce the same output, but the one that uses efficient LED lighting uses less energy to do it. Thus, its energy intensity, the number of joules of energy it takes to create a dollar of output, is lower. It's a more efficient business. Carbon intensity is a measure of how much carbon dioxide is emitted per joule of energy generated. In other words, this is determined by the technology being used to generate energy. If we look at the carbon intensities of various fuels, we see that the worst fuel for the climate is coal, which produces a huge amount of carbon dioxide per joule of energy generated. Oil produces about 25% less carbon dioxide per joule than coal, and natural gas produces about half the carbon dioxide per joule. But renewable energy sources, such as solar, wind, and non-renewable fossil fuel energy, like nuclear, have carbon intensities of approximately 0. The upshot here is that the choice of energy source has a huge impact on emissions. Putting this together, we can use the IPAT relation to write emissions as a product of four terms: population, affluence, energy intensity, and carbon intensity. Again, make sure you know these terms and the units on each one. This decomposition also gives us insight into how to solve the climate change problem. If our goal is to stop emitting carbon dioxide, in other words, make emissions go to 0, then one obvious way to do this is to generate energy using renewables or nuclear or some other technology whose carbon intensity is 0. If carbon intensity term is 0, then it doesn't matter what the other terms to do. The product, meaning emissions, will be 0. Remember this point because we'll talk a lot more about this in later chapters. So now, let's look at how these terms have been changing. First, let's look at population. As you can see, population has doubled since the 1960s. Second, let's look at affluence, which is measured in GDP per person. Affluence has nearly tripled over that same time. This means that you have twice as many people on the planet, and each person is consuming 3 times as much as they were in the 60s. If everything else were the same, that would correspond to 6 times the emissions today as there were in the 60s. I should note that this growth in overall affluence and consumption is generally good news. The number of people living in true poverty, less than about $2 a day, decreased from 40% of the world's population in 1980 to about 10% in the mid-2000s. As those people were lifted out of crushing poverty and strive for a middle-class life, they consume a lot more, and we should celebrate that. But recognize that this does come with higher emissions. While population affluence were increasing, energy intensity declined by about 30% over the past 3 decades. This occurs for 2 major reasons. First, because we pay for energy, there is a market incentive to manufacturers to produce more efficient equipment. Thus, a refrigerator you buy today is far more efficient than a refrigerator you would have bought 30 years ago. There are also abrupt decreases in energy intensity, such as that happening right now as we switch from inefficient incandescent lighting to high-efficiency LED lighting. Second, some types of economic activity take a lot more energy than others. It takes a lot more energy to produce a dollar's worth of steel, for example. That requires you to run a steel mill, run blast furnaces, run other heavy equipment. Compare that to how much energy it takes to produce a dollar's worth of computer programming, or a dollar's worth of a university lecture, or a dollar's worth of tax preparation. It takes a lot less energy to do those things. As the world's economy has grown over the last few decades, low-energy service sector jobs have grown faster than high-energy, heavy manufacturing, and this has driven an economy-wide decrease in energy intensity. Finally, let's take a look at carbon intensity. Carbon intensity showed big declines until about 2000. This was due to the world switching away from high carbon intensity fuels like coal and towards lower carbon intensity fuels like natural gas. In 2000, however, this trend reversed. This is due to a resurgence in coal, fueled in large part by the growth of coal-fired energy in China. If we look at the actual carbon dioxide emissions, we see that it increased by a factor of about 3 since the 1960s. Again, this is driven by an increasing population that is also getting richer and therefore consuming more, but it's offset by decreases in energy intensity and carbon intensity. So now we have a handle on what's going on in the past, and in the next video we'll turn towards what we expect in the future. And now, your moment of dog.